Okay, I'm sorry I'm not there today, but you're going to take Cornell notes along with this video. I'm going to try to make it quick so that you can get all the notes taken and then have time to do your quiz or any of those quizzes that I told you you were missing. This is finding mean. And our guiding question today is, how do you find the mean of a set of data? And mean is the same thing as average. So if you know how to find, say, the average of your grades, then you can find the mean. Mean is just another word for average. It says the mean is the most common measure of central tendency. It is an average, so it describes all the data in a data set. So when you ask your teacher what your grade is on your report card, you're asking them for the average, which is the mean. So it's something that you use all the time. Every 6 weeks, you're looking at the mean of your grades. And this is how we find it. We're going to teach you right now. Let's look at example 1. The picture graph shows, we're right here, the number of members on 4 different swim teams. Find the mean number of members for the 4 different swim teams. So the very first step is to add all the numbers. Okay? Add all the numbers. In your notes, write the first step. Number 1 is to add all the numbers. So the school that was called Amberley, they had 9. And the school called Carlton, there's 9 right there, so that must be 11. And then the school that was called Hamilton, they had 6. And West High had 10. Okay, so the very first step I said is to do what? You add all the numbers. So 9 plus 11 is 20, plus 10 is 30, plus 6 is 36. Now, 36 is not a number that you would say, you wouldn't say, oh, there's about 36 members on each team. No, that's not what you would do. The next step is to divide that sum. Divide the sum by however many numbers you added together. By the number, and we call those numbers add-ins of add-ins. Okay, so how many add-ins did you have? How many numbers did you add together? You had 9, 11, 6, and 10. That's 4 numbers. Okay, there's 1, 2, 3, 4 numbers you added together. So now you're going to take 36 and divide it by 4, and that equals 9. That is a very good number to represent how many members there are on each team. You can say there's about 9 on each team. When you look at the teams, there's only one that had 9, but the rest are pretty close to 9. Yeah, Carlton had about 9. They were 11, but that's pretty close to 9. Hamilton had less than that. West High had a little more, but they're all hovering around the number 9. That's how we find your grades. Right here, a set of data may contain very high or very low values. These values are called outliers. It's the number that doesn't really go with all the others. So when we look at number 2, it's going to include an outlier. Find the mean for the snowfall data with and without the outlier, then tell how the outlier affects the mean of the data. So we would add all these numbers together. In your Cornell notes, go ahead and add these numbers together. Set up an addition problem. Let's add them. That's going to be 9 plus 7 is 16, plus 4 is 20. 2, 4, 6, 7, 8. So there's 80. Okay, now we can't say, oh, the snowfall was about 80. That doesn't make sense because we haven't divided it yet. How many add-ins are there? 1, 2, 3, 4, 5. So we need to divide 80 by 5. Okay, and you get right here 16. Okay, so about 16. Now that's including the outlier. Can you tell which number is the outlier? Which one of these numbers seems really different from all the others? It's not even close. It's the number 4. Number 4 is the outlier. Okay? That's the one that's way far off. Now let's look at the mean without the outlier. We're going to leave the 4 off. So it's 20 plus 19 plus 20 plus 17. Okay? We're not adding 4 on there. And when you add those together, you get 76. And we're going to divide by 4 because that's 1, 2, 3, 4 numbers we added together. So 76 divided by 4 is 19. So what did the outlier do to your average? It actually made your average lower because 4 is a lower number than all of these other snowfall inches. All of the other ones were somewhere around 20, really close to 20, except for March. It was way down low. It was a number 4. So it wasn't very much. And because 4 was there, it brought your average down. It's like, let's say you had 100s, 100, 100, 100 on your quizzes, and then you made a 40. What's going to happen to your average? Well, that 40 brings it down. The 40 would be your outlier. Here, the 4 is the outlier, and it brought the average or the mean down. Without the 4, the average or the mean is really close to the rest of the numbers besides 4. With the outlier, the mean is less than the values of most of the data. Without the outlier, the mean is close in value to the data. You guys say data, I say data. I don't know why. Okay, number 1 down here. It says find the mean of the data. So what's the first step? What did you say the first step was? You have to add it together. So do that. Okay, there's 7, 15, 16, 25, 2, 4, 6, 8, 10. All right, so we got 105. Now, are we done? Is that the mean? No, we can't say 105 is close to all of these jacket prices. 105 is way more than that. These are the jacket prices. So what do we still need to do? We need to divide by what? Well, how many numbers did you add together? 1, 2, 3, 4, 5. So we set up the division problem 105 divided by 5. Okay, 5 doesn't go into 1, so now we need to go into 10. 5 into 10. 2 times. Bring down the 5. That's 1. All right, so 21. We can say that the average is 21 what? Dollars. Which jacket price is an outlier? When you look at this graph, which one is really far apart from all of the other jacket prices? That would be the $9 jacket. Find the mean of the data if the outlier is not included. So what are we going to do here? We're going to add it without the 9. And you know what I'm going to do? I'm just going to take off the 9 here by subtracting. I'm going to go back 9. And that would give me 96. And then what am I going to divide 96 by? I only have 1, 2, 3, 4 numbers that I'm using now. So 96 divided by 4 is 24. So the mean without that $9 jacket is $24. How does the outlier affect the mean of the data? What is that outlier doing to the mean? It's bringing the cost of the jackets down. It lowers the mean. Okay. So now we're going to look at, hold on, I had another worksheet on here. Where did it go? Okay. This is where it gets a little bit tricky because they don't give you just a bunch of numbers. We're going to find the mean of the data represented in each model? Well, the first thing you need to do is count how many there are in each. Like this looks like a bar graph. It's actually a pictograph, but you use it like a bar graph. You can see who has the most very quickly. Shamika. All right, so let's count how many are in each group. That Amber has 12. Dalton has 9. Juan has 10. And Shamika has 13. Okay, so what's the first step? Add them together. That's going to make 14. So you have 44 candy bars all together. Okay, that's how many were sold all together, but that's not what it's asking for. It wants the average or the mean. So we're going to take all those candy bars and divide them up into groups of 4. Okay, and 44 divided by 4 is 11. So each student sold, you could say, about 11 candy bars. And when you look at your numbers over here, each one of those is pretty close to 11. Let's look at number 2. Shoe size of students. Okay, whenever you're working with a bar graph, write the number that that bar represents above it. Okay, so we have 8. Michelle had 10. Carmen had, between 6 and 8, what would that be? 7. Jen had 9. And Alexis had 6. What's the first step to finding the mean? We need to add them all together. Okay, so there's 18, 25, 34, 40. So the sum of all of those is 40. Now how many shoe sizes were there? There was 1, 2, 3, 4, 5. So 40 divided by 5 equals what? 8. So all their shoe sizes were about 8. We're using the number 8 to represent the shoe sizes of the students. Not everybody had a size 8, but 8 is the number that we would use to represent that group. Okay, identify the outlier or outliers in each set of data. So number 3, which one is not close to the others? Number 3, would you say it's 4, 5, 3, or 1? Well, in this case, it would be 1. That's kind of a weird question. Okay, number 4, if you watch the video I made to review you for stem and leaf plot, you would know that that is 20, 21, 24, and 27. All of those are pretty close, okay? And it goes on 30, 30, 31, 35, 36. Pretty close to the group before it. And then we have 43, 46. So which one is farther away from the others? It would be 57. 57 is not as close to the others as the rest of them are. Okay, look at the last questions down here. Identify the outlier. When I come over here, that's about, those two are, whoa, what happened? I don't know how that did that. These two are close, 69 to 70, 70 and 73 are close. 73 and 35, that's not very close, but 68 is close to these others. So we'd say that 35 is the outlier. What is the mean of the data with the outlier included? So let's add them all together. That's 25, 8, 15, 22, 25. That's 31. I may have made a mistake. 1, 2, 3, 4, 5. No, I don't think so. Okay, there were 5 numbers that we added together, so we're going to divide that into the sum. Put this division on your paper. The outlier is, the mean or average is 63. Now 63 isn't really super close to the rest of those numbers. Why not? Because that outlier of 35 really brought it down. Okay, number 7, what is the mean of the data without the outlier included? So let's not include 35. Well, let's add it without. 69, 70, 73, and 68. 12, 20, 8, 15, 15 plus 7 is 22, 28, and 4 into 280. You guys should be doing division a little bit faster than what you do. All right, so without it, it's 70. Now look, 70 is closer to everything else, except the 35, the outlier. Number 8, how does the outlier affect the mean of the data? What did it do? Did it bring it way up or did it bring it way down? The outlier, we could say, reduced the mean. Okay, now you need to do quiz 2-6, self-check quiz 2-6. I will be looking for that in my email. Get it done.